Hello everyone, and welcome back to our discussion on rules and filtering in the Kubro Packet Master series of network packet brokers. Hot on the heels of our previous two videos where we looked at protocol filtering in the WebGUI interface, we are now going to take a look at the CLI syntax for those same protocol filters. So I'm already in the command line of my EX32. Let's just jump in and get started. As we saw in previous videos, anytime we add a rule to the Packet Master, we have to start off our command with cc add flowbridge 0, and then we can start passing our arguments. The first being our ingress port or ingress ports. So I'm going to do import equals 1, and then our priority, and I'll stick to the GUI default of 32,768. And from here, we also saw in previous videos, we can start doing like VLAN filtering or MAC address filtering, but in this video, we're strictly looking at the protocols. So our first argument is going to be IP. We saw in the drop-down menu in the GUI that IP was the first protocol in the list. Seems like a good place to start. So this IP argument on its own will be sufficient to filter out all IPv4 traffic on the device. And if we wanted to, if that's all we wanted to see, we can just follow this up with our action string, and there's our first rule. Now I'm careful to point out here that it's IPv4 traffic. In the GUI, I mentioned that we would look at IPv6 in a different video. In the GUI, IPv6 and IPv4 just fall under that same IP banner, but in the CLI, there's slightly different syntax for filtering out IPv6 traffic versus IPv4. So this is IPv4, and we'll do the IPv6 in another video. Now we also saw in the WebGUI that filtering on IP, we can of course filter on a source IP address or a destination IP address, or both at the same time, and we also had the option to filter on a protocol number. So if we want to filter on a source IP address, we're going to add a NW_SRC, and then our IP address of interest. And if we wanted to filter on a destination IP address, we are going to use an NW_DST and our IP address of interest. So if we wanted to use these in tandem to filter on both a source and a destination, we would just put in an NW_SRC equals some IP address, and an NW_DST equals the other IP address, and then we'd be filtering out all of the traffic originating from one host and destined to the other host. Now, we also saw in the WebGUI that when it came to IP addressing, we were able to add a dotted quad as a subnet mask or CIDR notation as a subnet mask so that we could filter on a subnet rather than just a single IP address. And we can most certainly do that here as well. So right after you type in your IP address, /, and then if you want to put your CIDR notation in there, you just go ahead and throw that in. Or if you prefer to use the dotted quad, you can do something like a 255.255.0.0. Both of those work just fine. And I'll point out that when it comes to the dotted quads, you can use arbitrary subnet masks too that don't necessarily fall within a CIDR block. That's perfectly acceptable. Now, as far as filtering on a protocol, to filter on a protocol, we're going to use the argument IP_proto equals, and then our protocol number. So we could do like 1 for ICMP. Although we already know that we have better ways of filtering on ICMP, this is an option that we have here as well. So this is where things are going to get slightly different because we've just covered all of the options that we had available to us in the GUI. But there's actually some more things we can do here in the command line that we can't do in the GUI. And whether or not they're valuable or not to you, I'll let you be the judge of that. But since they're here, we might as well discuss them. So another argument that we can add, or another filter that we can do via the command line, is to filter on the differentiated services code point. And to do that, we do an IP_DSCP equals, and then our code point value. And I'll use a 48 because I can actually demonstrate this in a PCAP. But let me go ahead and delete all of my rules first so that we only have this one rule filtering traffic. And then we'll jump over to Wireshark and we'll start our capture. And I'll go ahead and play back our trusty VLAN PCAP that we've been using since the beginning, and we'll see what we get. And as you can see, we managed to filter out these RIP-v1 responses. And if we take a look down here, we can see that they have their differentiated services code point set to 48. So that works just fine. Now, another interesting thing about this is if we do a dump flows right now to look at our rule table and then take a look at that rule that we just added, we'll see that the command line or in here, it actually converted this IP underscore DSCP equals 48 to a network underscore TOS equals 192. So in fact, we can also filter on type of service. This being a deprecated protocol that I'm not sure how much use it actually ever got outside of the DoD. Don't know how useful this is, but it can be done. So you could put in under NW underscore TOS and then your type of service value that you're interested in and create a filter from that. One more that we can do is to filter on the explicit congestion notification value. And to do that, we would do an IP underscore ECN and then our congestion value of interest. I believe the valid values there are 0 through 3. Now I can't actually demonstrate either of these two in a PCAP because as far as I know, I don't have any captures where either of these values are set to anything other than 0. But they are options that we have here in the command line. So that covers up IP and the options we have when filtering on IP. Next up would be TCP. So to filter on TCP, start building up our rule again. So CC add flow bridge 0, and then our import equals 1 in my case, and a priority. And then we would put in our argument for filtering on TCP, which is TCP. And again, if all we wanted to look at was the TCP traffic and nothing more granular, we can fill in our action string and we're good to go. The syntax for TCP filtering on a source IP address and a destination IP address is exactly the same as above that we saw here in IP. So if you wanted to filter on a source IP address, it's just NW underscore SRC and your IP address. And then for your destination IP address, NW underscore DST and your IP address. But then our new options here are filtering on a source port and a destination port. So to filter on a source port or a destination port, or both, source port is TCP underscore SRC and then your source port, and destination port is TCP underscore DST and your destination port. And of course, you can use as many or as few of these arguments in any single rule that you want. So if you wanted to filter on, two hosts, as well as a source port and a destination port, let's say we want to filter everything coming from this 1.1.1.1 and destined to this 2.2.2.2, but originating on TCP source port 6500 and destined to TCP port 80, our rule would look like this. Okay, so UDP, very similar syntax. Really the only thing that changes are the fields where we see TCP here. So to filter on UDP, we could of course use the UDP protocol argument. And then again, our source and destination IP addressing syntax is exactly the same. The only thing that changes is we want to change this to UDP underscore source for our source port and UDP underscore DST for our destination port. And this is how we would construct our rules for UDP. Same thing with SCTP. Just change your protocol argument to SCTP. Filtering on your source IP address and your destination IP address, exactly the same. And then, of course, we want to substitute SCTP underscore SRC for our source port and SCTP underscore DST for our destination port. Okay, moving right along, we have next up ICMP. Here again, ICMP, let's do an add flow bridge 0, import equals 1, priority equals 32768, and then our argument for protocol, ICMP. Not too surprising at this point, I'm sure. Okay, so ICMP, once again, source port or source IP address and destination IP address, exactly the same syntax, nothing's changed there. What has changed is, of course, now, rather than filtering on source and destination ports, we have the option to filter on a code and a type. So let me finish this out right here. So if we wanted to filter on an ICMP type, like type 3 that I did in my example in the web GUI, we would just use the argument ICMP underscore type, equals 3 for destination unreachable. And then if we further wanted to filter on a code of some kind, ICMP underscore code equals also 3 for that port unreachable, I believe that was. And then our action string. And then, just probably repeating myself here, but if you only wanted to filter on ICMP traffic in general, you just put in the protocol flag and that's it. All right, next up, ARP. We saw in the web GUI that ARP really didn't give us any other options. We selected ARP and ARP was just ARP. There were no additional parameters that we were to put in for that. That's a little bit different in the command line. So for ARP filtering, let me go ahead and clear my rule table again. And build this rule up once more. For ARP, put in our protocol argument of ARP. And again, if we just wanted to filter on all ARP traffic, the same way that the GUI kind of lets us do, we put in our action string. But we can do a little bit more here. So with ARP, we actually can use the NW underscore source as well as the NW underscore DST and provide an IP address. And in the context of ARP, what this is really doing is this is using the NW underscore source and NW underscore DST to filter on the source protocol address and the target protocol address within the ARP message. So actually, we can look at this in our dump flows. If we dump our rule table, we can even see that this converted that NW underscore SRC to an ARP underscore SPA for source protocol address, and it converted the NW underscore DST to ARP underscore TPA for target protocol address. So either of these are valid syntax for accomplishing this. You can simply use the same NW underscore source and destination that we used above, or you could actually specify this as ARP underscore SPA and ARP underscore TPA. And this is another one that I can demonstrate. So let's bring this back up and let's actually just put this in with the ARP underscore SPA and ARP underscore TPA arguments. And this actually gives me the option or the opportunity to point something else out that I didn't point out before. With these command line only sort of options that we have here, if we go back to the web GUI, we can indeed see that the rule added here is filtering on ARP. We see the other parameters that I put in, but we don't see that target protocol address or that source protocol address that I specified. We don't even see that pop up as an IP source or an IP destination. So the GUI doesn't perfectly reflect these parameters that we're doing in the CLI sometimes if the option's not already in the GUI. But rest assured, we are actually filtering on this, and although we are filtering on the wrong IP addresses. So let me just fix that real quick. So I'm going to filter on a source protocol address of 69.76.216.1, and then our target protocol address is going to be a 69.76.223.235. And we'll fire up our capture again here, and I'm going to grab a different PCAP. And now it might take quite a few packets for us to see this, but we can see that we are getting some ARP broadcasts here. And if we take a closer look at these, we can see that the sender IP address is that which we specified, and the target IP address is also the one that we specified. So these filters work just perfectly. Okay, another thing that we can do here while we're in ARP is we saw if we specify IP, we can filter on an opcode by using the protocol number, and we can do that in the CLI or the web GUI. However, in the CLI, we can actually specify ARP as the protocol, and we can filter on the opcode directly. And to do that, we would use the arguments ARP underscore op equals, and then 1 for our requests and 2 for our responses. So another option that we have here with ARP that isn't in the web GUI. And again, to throw in some of our deprecated protocols, we can actually filter on RARP as well. So reverse address protocol resolution. And we would do that just by specifying RARP as our protocol of interest. Now with RARP, we don't get to filter on a source protocol address or a target protocol address or even an opcode. It's just RARP, you're filtering on that. But if you have RARP in your environment to filter on, rest assured you can filter on your RARP. Okay, now the last thing to touch on here is the custom match. Well, I guess in the GUI we saw MPLS, but I also said we'd cover MPLS in a different video. So yeah, MPLS is here, but we're going to cover MPLS in a different video because there's a fair amount to talk about there. But below MPLS, we saw our custom match in the web GUI, which allowed us to specify an ether type. That exists here in the CLI too. However, this would be the one instance where we don't simply put custom in as our protocol field. So that is a no-no. That doesn't work. What we do specify here is DL_type. And DL_type is just where we put in our ether type. So if we wanted to filter on IP, again, we have better ways of doing this, but we could do this. We could filter on DL type 0x0800, and that would filter out all of our IP traffic. Or as per my other example in the web GUI, we could do fiber channel over Ethernet, which I think was 8906. So that's an option. And then along with this, we can also specify our IP proto. So let me change this back to IP, and then this would be a filtering on ICMP again. So what's the difference between this and when we originally showed way back up top filtering on IP and then specifying IP proto equals 1? There is none, actually. All of these protocol arguments that we've been showing so far, IP, TCP, UDP, SCTP, ICMP, ARP, RARP, these are all just built-in shorthands for this DL type. And I'll list those over here. Of course, they're available online too, or that Wikipedia article I showed you. But these are just, like I said, built-in shorthand, so you don't have to type out this DL_type equals whatever for each of these arguments. Now, if you're using any protocols that aren't what we've already covered, there is no shorthand available for those. So that's where your DL type comes in, and also the ability to specify your proto. So that pretty much wraps up the command line syntax for these protocol filters, at least for now, until we touch on MPLS, which, speaking of, MPLS will be our next topic. So in the next videos, we're going to jump into MPLS filtering and the differences between the non-G4 devices and the G4 devices. We're going to cover the web GUI first. So until then, thanks for watching, everybody, and take care.